Good morning, everyone present here. Today we have our speaker, Dr. Utkarsh Mahadev Khere, currently working as assistant professor in G.H. Raisoni College of Engineering, Nagpur, in the Department of Computer Science and Engineering. Dr. Utkarsh received his BE in Information Technology from Nagpur University, Maharashtra, India, and MTech in Computer Science Engineering from National Institute of Technology, Nagaland, India, and received his PhD for risk prediction and prognosis of life-threatening diseases based on healthcare data from National Institute of Technology, Nagaland. Dr. Utkarsh is an expert in data analytics, machine learning, data structures and algorithms, operating system, architectures and organization, and optimization techniques. Dr. Utkarsh has published 7 research papers in national and international journals and 2 research papers in international conferences. Now I welcome Dr. Utkarsh to handle the session, sir. Sir, please. Sir, you can start the session, sir.
Utkarsh, you can present your screen and you can start your session.
Okay, ma'am. Is my screen visible, ma'am?
Yes, it's visible.
Hello?
Yes, it's
Yes, sir.
visible.
Okay. I'll start now, ma'am. Okay. So, good morning to all. Okay. So, in this session, we will see the basics of Python. Okay. The introduction, the API which we are using. Okay. And in the basics of Python, which includes variables and the list, tuple, sets, dictionaries, strings, control structures. In control structure, we will see the if condition, the for loop, while loop. Okay, and then we will see the functions, how to define a function in Python, and how to access and how to declare a functions. Then in that function we will see the nested functions and various examples of functions. After that, we will see how to include Python library into our code. Then in file handling, we will see the how to import a file into your code. Then the operations of that file. After that, we will see the basics libraries which we are going to use in Python, such as NumPy, okay, and then pandas. Then after that, we will see the plotting of our data set and the visualization of our data sets. Okay, so for these sessions, I am using Google Colab. Okay, so Google Colab. So most of you are known with Anaconda. So Anaconda also includes a Python notebook. Google Colab is also a Python notebook, but instead of it's running on your system or occupying a space of your system, it will run on a Google server. So it is handy in various scenarios, such as uh, from the point of view of importing your data set and loading your data set, and it is faster as compared to Anaconda, because it's running on a Google server. So it will not consume the capacity of your system. So we will start with the basics of Python. So first, here I have already write a code so that we can save our time and we will cover more topics. So in the end of session, I will share this Python notebook with you along with the data set, so that you can proceed. Here the print statement. Okay, how to print your output in your code. So here simply you have to write a print, and in the parenthesis you have to write your statements. Here I'm running this sale. So after processing, it will print hello. Then similar to other languages, in Python also we have variable. We have to declare a variable. So the declares may be numerical, floating value, character, or strings. Okay. So here in other languages, such as in C, in Java, we have to define a variable type. But in the Python, we don't have to declare a variable type. Simply you can give a name, the name of your variable, such as number, and then you can declare your variable, such as number is an integer variable, then float number, then character. Character also you have to take it into single quotation. Then string variable. After running this, so I am printing each and every variable here. It will print. Okay, so here I am printing the number. So here in the print statement, I am printing a number. The name of my variable is a number, and then at the same time I am printing the type of that variable. So here this type, this this type is printing, or telling me the name. What is the type of that variable. So here the number is an integer type variable. Then this float number is a float type variable. This class, okay, the class is a float, and then a is a string type variable, and hello world is a is a character type variable, and hello world is a string. Okay. Then in Python you can do a simple operation like here I am taking two variables, a and b. A is 6 and b is 2, and simply I am using arithmetic operations such as a plus b, a minus b, a into b, a divided by b, and a mod b. So simply I can print the output, or I can print the results using the simple arithmetic operations. You don't have to do anything for this. So this is the advantage of Python. Then okay. Then the thing is, if you are using a Python notebook, uh, uh, here for printing, various output, you have to write a print statement here. Similar like here, I have written various print method in order to print each and every output. But sometimes if you don't use this print statement, it will print the last operator. it will print the result of this last operation. See, if we can see here, it will print a mod b 0. It will print the output of this only last operation, but it's not acceptable. So what we can do here in Python, there is a provision, okay, or we can say in the Google Colab it's a provision, or in this notebook there is a provision from importing this python.core.interactive shell. We have to import this interactive shell, and then we have to set this interactive shell .asp node interactivity equal to all. So after running these cells, what we can, it will print the output for each and every operations. We'll see the output is not in proper manner, but see, this a plus b is 8, a plus b is 8, then a minus b is 4, and then a into b is 12, and then a mod b is 3. So after running this cell, so if you want to print each and every output in your cell, then you have to import this statement in your Python notebook. Here, if you want to take input from user, then you can use this input statement. So here I am taking, I'm declaring one variable which is a number, and then I'm using this statement input in bracket, enter a number. So after running this, it will give me an option to add a number. So suppose if I insert the number 6 and then hit enter, it will print the number. So it will print the number whatever I have inserted, and it will print the type of that variable. Okay, so here by default, if you are using this input statement, and if you are giving any input, it will take as a string. Okay, so for that, if you so here I insert a 6, but I insert 6 from the I think it is I want 6 as an integer variable, but the Python take it as a string variable. So I have to convert that string variable into an integer variable type. So I have to casting that variable. So in order to cast that variable, we have to simply write int. Similarly here, we have to simply write int in the bracket input, and then in the bracket enter your number. Okay, so it will now if I entered 6, it will print 6. Now see here, the class, the type of that variable is string, but here the type of that variable is integer. So it is called the typecasting of your variable. So this is very handy procedure in a Python as compared to other languages. Then now we'll move on to the built-in data structure in a Python. So in Python we have various data structures such as list, tuples, and sets, dictionaries. Okay, so the difference between this data structure is that list and dictionary and set are the mutable data structures. Okay, whereas the tuple is the immutable data structures. What is the mutable and immutable? So the mutable is that you can modify the content of your data structures in runtime. Okay, so that is the mutable. And whereas in the case of tuple, you can't modify the content of your data. So that is the immutable. Modify the content means you can't insert. You can insert, you can delete, or you can change the position of your element in your data structures. So that is the mutable. So that facility is not available in a tuple. So we'll see some of the examples here of list. Okay, so here I'm creating a list, and here I'm creating a list of marks. Okay, so in that in the list of in this list, 35, 68, 96, 80, and 90 are the elements. So this is simply, if you want to create a list, you can this is the syntax for creating a list. You have to take a square bracket, and then you have to add the numbers. That's it. Now suppose you want to see what is the indexing of your string. So in Python, as compared to other languages, in Python the indexing of your data structure is start from 0. In other languages maybe it start from 1, but in Python it start from 0. So you have to think according to that. Suppose you want to access any variable from your data frame, or from your list or from your dictionary, you have to start from 0. Okay, so see here, now I want to know the indexing. Now if I want to access the element at the 0th position, so simply marks in the square bracket, I gave the index of, so this 0 is the index of this index of the particular element. So see here in the marks, so the 0th element is 35, 1st element is 68, then 96, 80, and then 90. Okay, so 0th element is 35, so it will print 35. Then suppose I want to access the last element of my list. So the last element of my list is this 90. Okay, last element of this list is 90. So in order to access the last element, there are two options. You can do marks, marks in square bracket. You can take a length of marks minus 1. Okay, so in that case also it will print the last element. So here it already print the last element of our list. Okay, as well as you can directly you can write marks in square bracket minus 1. Okay, minus 1. So in that case also it will print the last element of your list. Okay, now suppose I want to reverse a list. Suppose I want to reverse the element of this. Suppose I want to reverse the element of list. So instead of writing a rigorous for loop, we can simply, so in Colab, suppose you want to take a new cells in which you want to write some codes. So here you have to go to previous cell. It will give you the options whether you want to code cell or a text cell. Okay, suppose if I choose a text cell, okay, so here you can add some text. So here you can give suppose if you know the LaTeX, you can give the LaTeX, you can give the LaTeX expression also. LaTeX expression means suppose you want to write any mathematical functions. In that case you can simply write a LaTeX syntax of that mathematical functions, and automatically it will generate that particular mathematical functions. Otherwise, if you want to if you want to take any, like suppose you want to create a new session, then simply you have to write here new session. That's it. So suppose if I write session, and then in order to print this, either you can go here in runtime, and then you can choose anything, run all or run before. Okay, or simply there is a shortcut key to run these cells. You have to press enter and shift enter at a time. Okay, so that is the code for running the cell. Okay, so now I want to reverse the element of this list. Okay, I want to reverse the element of this list. So I don't want to write a rigorous for loop. So there is a provision in Python. You can simply write marks in square bracket minus 1 and then double column. That's it. Okay. So here simply I was writing the wrong code. So here simply you can do this and it will reverse the element of your list. That's it. You don't have to write a rigorous for loop for reversing the element of your list. Okay. So now we'll move on to the slicing of your list and accessing the element or inserting or modify the element of your list. Okay. So here the 0th element I'll remove this. I'll remove this cell. Here now in my original list, the zeroth element is 35. Okay, so but now I want to change the content of my list at the zeroth level, at the of the zeroth element. So simply I can state here the marks of 0 equal to 38. So it will replace this 35 with the 38. Now see, previously our list was 35, 68, 96, but now the list is 38, 68, 96. Okay, so the 35 is replaced with 38. Now suppose you want to slice your list. Slice means suppose you want to extract the element from your list. Okay, what are the important element from your list? Suppose if you know the indexing of the element in your list, then you can simply give the index of that element, and you can extract the content. Similarly, see here, the suppose I want to extract the element from zeroth index to the length of my mark. So length of my marks is 5, so 0 to 5. So it will give me the whole list. Okay. Now similarly, sometimes I don't want to write a zero. So simply if you write a colon and then length of marks, it will print the your whole list. Similarly, marks in square bracket 0 to up to the last element of your list. In that case also it will print the whole list. And some and in this case also, instead of giving any indexing or any index value, simply by giving a colon you can print the list, the whole list. Now suppose I want to access the elements from the 2 to 4. 2 to 4 means, so this is the zeroth element, 38 is the zeroth element. 0 1 2 3 4. Okay, 0 1 2 3 4. So here I want to access the element from 2 to 4. Then, but it will not access the fourth element. It will access the 4 minus 1, that is the third element. So it will print 96 and the 80s. It will print these two elements, 96 and 80s. 96 and 80. Okay, so see here, I want to print the element, or I want to print the list from 2 to 4. Okay, so the 2th element is 96 and the 4th element is 90, but it will not print the 4th element. It will print 4 minus 1, that is the third element. So 96 and 80. This is the case. Now suppose I want to add any element, or I want to remove some element from my list. In that case, you can simply use a function which is a predefined function in Python, that is the append. Okay, so marks dot append. Append means it will add one element to the end of your list. Okay, so after 19 it will add element 89. Okay, so here if I print this marks dot append 89, so at the end of my list I want to add suppose 89, so it will add, or it will insert one element in the last position of my list. Okay, and suppose if I want to insert any element at the specific position, so here I can use this function dot insert function. So marks dot insert 1 comma 70. Okay, so it will add, or it will insert 70. This is the element, and 1 is the position. It will insert a 70 at the 1st position in my list. So here if I print this, if I print the list now, it will add, see, so the 38 is the 0th position and 68 was at the 1st position. But now after running this operation, 70 is at the 1st position, and similarly it will all the elements, the rest of the elements shift their position to the right. Okay, now suppose I want to remove some element. Suppose I want to remove this 70 from my list. So simply marks dot remove. You simply by using this function you can remove any element from your list. Okay, so here I have already removed the 70. So now list my this is the original list. Now suppose I want to sort the element. Now the element of my list is unsorted, but suppose I want to sort the element in my list, then simply I can use the predefined function in Python, that is sorted. So the sorted then I want simply by using the sort, see my the whole list is now sorted. By using this sorted function, I can simply, this is the one line code. With the help of this function, you can simply sort your list. Okay, and then after sorting, suppose you want to reverse. Okay, so suppose you want to reverse the content of your list, you can you can use the reverse is equal to true. There are there are numerous provisions in Python. Means if you are using any functions, then you can pass various
Excuse
attributes.
me. Sorry to interrupt. A few participants are facing a voice breaking problem. Maybe if you switch off video, we will have a better audio clarity, I think so.
Okay, 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 sir.
Thank you.
Is it fine now, sir? Hello.
Yes, Professor, you can proceed.
Okay. Okay.
Thank you. Thank you.
Yeah. So, as we discussed previously, suppose this is also a thing like after sorting, if you write a reverse is equal to true, it will reverse the element of your list. Otherwise, you can use marks in the square bracket colon colon minus one. It will again reverse the content of your list. Then this is the list comprehensions. Okay, so in list comprehension, suppose I declare one variable pass mark is equal to 15. Now I want to check how many students are passed. Okay, in my list. So suppose now I want to check how many students got the marks more than 15. Okay, so similar. So here I wrote one statement that mark. Okay, mark for mark in marks if marks is less than pass marks. Okay, so if I execute this statement, it will give me, okay, it will give me the list in which it will say this student is not passed. So in our original list, there was 6 elements, but now after running this statement, the element of my list is 5. Okay, so simply I am doing here, instead of writing a code in 2-3 lines, I can write a statement in a single line. Okay, so this is also an advantage of Python. Then here we are using the lambda functions. Okay, so lambda function. So here a is a variables in which I am taking a list of element from 0 to 5 or 0 to 4. Okay, so range will give me the element from 0 to 4, because in Python the indexing is starting from 0. Therefore, it will give me the element from 0 to 4. Now, simply I am doing what I am doing. I am simply taking the square of each and every element in that list. So see here, after executing this statement, it will give me the list which is starting from 0 to and which is starting from 0 and end at 4. Okay, 0 to 4, and simply now I want to take a square of each and every element of this list. So simply by using the lambda functions, so lambda x colon x square and a is the list. Okay, so simply by using the lambda function, I can take a square of each and every element in my list. Okay, so that is the all basics about the list. Now we'll move on to the tuple. Okay, so the tuple is also similar to the list. It will also contain the data element. Okay, it is an ordered collection of data, but list is a mutable data structure, whereas the tuple is the immutable data structure. Okay, and it allows the duplicate element in your tuple. Okay, list also allow the duplicate element. Okay, tuple also allow the duplicate element, and then you can create a tuple with the help of round bracket. Okay, see here. Here we are creating a tuple. So now, while creating a list, we use the square bracket. But here we are while creating the tuple, we can use the simple bracket. Okay. Then suppose I want to find a indexing. Okay, so similar operations indexing to we can identify the indexing of each and every element in our tuple. Okay, and then suppose I want to modify. So in list, suppose I want to modify the zeroth element. Simply I can write a statement marks of 0 equal to 38. But in my tuple, if I want to modify the content of element, I can't do that because it is an immutable data structure. See, if I want to modify the content of the zeroth element, it will give me an error. It will give me an error that tuple object does not support item assignment. Okay. Then in any language, like suppose you want to add some comments. Okay, so adding a comment is also an important part. So in Python, you can add a comment by assigning a hash operator. Okay, assigning a hash operator in front of the statement. Okay, suppose I want to comment multiple statements. Then we can select. We have to select the statements, and then simply you have to press. There is a shortcut key, control and question mark. Okay, so it will comment a multiple statement. That's it. Then suppose I want to similar to the list. Suppose I want to add the element at the end of my list. Okay, and I want to remove and I want to insert an element at the specific position. That operation also I can't apply on the tuple because tuple is an immutable data structure. Then in the case of slicing, we'll see we are accessing the element. Okay, so the accessing the element from 0, the whole tuple we are accessing. So similarly, like a list, we can access the element from the tuple. There is no issue. Then tuple comprehension also. So in that case also, while writing a statement in a single line, you can pass the condition and you can access the element from your tuple. So here marks. Okay, so here I am accessing the marks for mark in marks. So marks is my original tuple list, original tuple. If mark, every element in mark is greater than pass mark. So pass mark is 50. So similarly, it will give me the result. Then we'll see what is the difference between tuple and list. So if I want to use, if I whether you want to use a list or a tuple. So how we can compare? We can compare the time required to execute the operation on both the data structure. So here I give the code in which it's taking the it will take a list of element. Then it will do the operation, that is the square each and every element from that list. Okay, and then here I give the code for starting the time, and after doing the square of each and every element in my list, I'm stopping the time, so that, and in the end I am printing the time required for that particular operation. So here if I choose if I take the list of this many elements, okay, in my list, okay, it will take the time of 0.96 seconds. Okay, 0.96 seconds. But if I take the tuple, and if I apply the same operation on every tuple, on every element of that tuple, it will take less time. Okay, so as compared to list, tuple will take less time to execute. Okay, so that is the thing. Then now we'll move on to the sets. Okay, so sets is also an ordered collection of data, and it is a mutable data structure. Uh, uh, but uh, but as a list or a tuple, it will not allow the duplicate element. Okay, so set contains all the unique elements. Okay, and it is created by using this curly braces. Okay, so here I'm creating a set. of named cities. Okay, so in this set, it contains various cities. Okay, such as Madras, Delhi, Bombay, Calcutta, and okay, Madras. Okay, so see here, it will not allow the duplicate element. So simply because I already I used this Madras twice, it took only single Madras. Okay, so it will not allow a duplicate element. Whereas if I choose the list, or if I take the list or tuple, it will allow the duplicate element. That is the only difference. Then in set operation, as we know, on the set we can apply various operations such as union, intersection, set difference, or symmetric difference. Okay, so that operation you can directly apply in Python by using this operator. Okay, so see here. So this is the union. This is the union of set. Okay, 1, 2, 3, 4. A set contain 1, 2, 3, 4 element, and B set contain 4, 5, 6. Okay, so if I take the union, it will give me the set of 1, 2, 3, 4, 5, 6. Okay, and then intersection, it will take the common element of these two sets. In the set difference, it will take. So I am doing the operation A minus B. So it will take the element from set A, which is uh, uh, which is not included, in a B. Okay, and then the symmetric difference. Then we can add or remove the element from sets, because as I already told you, set is a mutable data structure. So simply similar to the list, you can add or remove any element from a set at any time. Okay, then the next data structure in a Python is the dictionary. Okay, so dictionary is a mutable data structure. Okay, so in all the data sets, in all the data structure of Python, only tuple is the data structure which is immutable. Rest of the data structures are mutable. Okay, and then similar to the sets, dictionary also declare with the help of curly bracket. Okay, and then it will contain a key value pair. Okay, so we'll see some examples on a dictionary. Okay, so here I am creating a dictionary student where I'm taking a name, registration number, and the course. So these are the features. These are some features of the students. Okay, and then I'm printing, clear the output. So now here, okay, so this is student is a dictionary which contains name. So here name is a key, and Gokul, and this registration number and the course is the value. Whereas name, registration number, and the course is the key. Okay, then I can access all the keys, all the values, and all the items. Okay, suppose you want to know what are the keys in your dictionary. So simply you can type student.keys. Okay, student.keys. It will print all the keys associated with your dictionary. Similarly, if you want to see what are the values of your dictionary, what are the value contained in your dictionary, simply you can write student.values. It will print all the values in your dictionary. Okay, and the item, it will if you write a statement student.item. So student is the name of your dictionary and item is a function. So it will give you the key value pair of your dictionary. That's it. Okay, so now suppose you want to access the element from your dictionary, you can simply write a for loop for key value in student.item. So it will print accordingly. So it will print accordingly key value. Okay, so if I execute this statement, so see, so this is the content. So key is a name. It will print the key is a name and value is the Gokul. Okay, so similarly, it will print all the key value pair in your dictionary. This is a simple operation for accessing the element from your dictionary. Okay, so now we'll move on to the strings. So the string, as we all know, the string is a sequence of characters and it is immutable. So similar to the tuple, string is also immutable. Okay, so it is created by, or you can declare a string variable with the help of double quotes. Okay, so here word is a string which contain a Malayalam. Okay, so now if I print this statement, it will print the Malayalam. Okay, now suppose I want to apply. So in the case of like if you are working in the area of NLP, natural language processing, in that case this is very helpful. Like and in Python there are predefined libraries also, or inbuilt libraries with the help of such as NLTK. Okay, with the help of them you can perform basic and advanced operations on in the area of NLP. Okay, so suppose I want to convert this Malayalam into lowercase. So simply you can write this function word dot lower. So word is my variable which contain a Malayalam, and then word dot lower. So it will convert your Malayalam into the lowercase. Okay, simply if you want this Malayalam into uppercase, so word dot upper. So there are pretty basic functions and very easy. Okay, so simply if I run this cell, it will print it will print Malayalam, okay, in the lowercase, then Malayalam in the uppercase. Then suppose I want to find what is the length of my word. So simply you can write length of word, which will print 9. Okay, so Malayalam is a 9-letter word, so it will print the 9. Okay, and then suppose I want to find whether it start with A or end with M. Okay, so simply you can write the statement word dot start with A or word dot ends with M. So it will give it will give you the output. Okay. In suppose this is useful if you are using a like if loop, and if you are doing some operations in the case of NLP. Like if you want to process any text file. Okay, suppose you want to extract some data from very large text file. In that case, this is very useful. Okay, so slicing a string. Okay, so slicing a string means like the in list suppose we want to extract the element from particular from start position to the end position. Okay, and if you know the indexing, then that is the slicing. Okay, so suppose I want to access the word, or I want to print the word which is the or the character by character from 0th character to the 5th character. So I can give the word in the square bracket 0 to 5. It will print the output. Then if you want to convert this string into the list means every every character of this string will be converted into a separate element. Okay, separate element. So simply you can write this statement list of word. So simply now the Malayalam that previously it was as a string. Now every element of this of that string is converted into a separate element, and now it's act as a string. Now you can apply the string operation on this. Now you can apply the list operation on this string. Okay, whatever the operations included in a list, you can apply all those operations. Okay, so now suppose I want to split this sentence. Okay, so the sentence is I love deep learning, and I want to separate each and every word. So simply you can write word is equal to sentence dot split. Okay, so it will separate each and every word from your sentence like this, and it will create a list. So now previously it was the whole sentence. Now you can access every every word separately. Now suppose you want to find the what are the suppose you want to know what how many words are in particular paragraph or in particular sentence. Then simply uh, you can you can use this statement length of words. That's it. Okay. Now we will move on to the control structures in a Python. Okay. So control structure contain the if statement or a if else statement, then for loop, while loop. We will see the syntax of every control structure in Python with the example. So here I took two variables A and B. So A is a 3 and B is a 5. And suppose I want to check whether A is greater than B. So if this condition is true, and there is one thing in Python. Okay, unlike other languages, suppose in C, in Java, if you are using a control structure or for or if conditions, you have to write a curly bracket. You have to write a loop or the condition in a curly bracket. But in Python, you don't have to write the statements in curly brackets. You have to use the indentation. So this is the indentation. So suppose uh, my if loop is my if condition is starting at this position. Okay, and if I start my print from this position, it will give me a indentation error. Expected and intended block. Okay, so simply simply you take your cursor and then hit enter, it will automatically intend. Otherwise you can do one thing, you can put your cursor here, or you can give one tab. That's it that's it. So you have to be very careful while writing a code. If your code is not if your code is not intended, it will give you an error. Okay, so simply it will take the condition whether A is greater than B. If the condition is true, this print statement will execute. Otherwise it will not execute. So we'll see now. See now. So here A is smaller than B. Okay, so this condition is false. It will not execute this print statement. Okay, so it will not give you any output. But in the case if I use the else statement, okay, else statement. So if A is greater than B, it will print A is greater than B. Else it will print B is greater than A. So now see, now A is greater than B. So condition is false. So it will not execute this statement. Our control will go to the else part. Okay, and then it will print this statement. B is greater than A. Okay, so let's take. We'll see another example. See here, the score is 80. Okay, and the grade is none. Now I want to give the grade for this particular score. Okay, so here I'm writing, if a score is greater than 90, give the assign a grade to A. Assign a grade A. Else if a score is greater than 80, it will assign a grade B. Else if a score is greater than 70, it will assign a grade C. Similarly, now in the final condition, else grade F. Okay, so if I execute this cell, it will print grade is C. So see here, the score is 80. Now the score 80 is greater than 90. Condition is false. So our control will go to this statement. 80 is greater than 80. Condition is false. So our control will go to this statement. 80 is greater than 70. So condition is true. So it will print the C. Okay, so this is the printing statement. So grade, and then here you can use a plus sign. Okay, and then you can write a variable, so that whatever the variable you want to print in your output, you can give in a print statement, similar to C and Java. Okay, now we'll move on to the for loop. Okay, so for loop is for iterating to your data set. Suppose you have a very large data set and you want to perform some operations like pre-processing your data sets and all. In that case, this control condition, or in that case, our control conditions are very useful. Like see, now here I took one here I took one list which contain the name of students. Okay, and then I am accessing the each and every element from my list. So for person in OFL team, okay, OFL team. So and then it will concatenate the person name with the particular mail ID. Okay, so if I execute this cell, it will give me the mail ID for the particular student. So see now, Mitesh at 14lab.com. Okay, 14lab.com. Pritish at 14lab.com. Okay, so this is, so it will in the for loop, what it is doing, it is taking each and every element from this list. Okay, and then it is concatenating the, or it is concatenating this mail ID to that particular student name. That's it. Then here it's taking. Now we'll see what will happen if I execute this cell. Okay, so here what I did, I declare one list. Okay, and then I access each and every element from this list with the help of this statement, person in OFL team. But instead of that, we can do we can use this statement also for I in the range of length of OFL team. Okay, so it will execute from 0 to end of this list. Okay, and then OFL team of I. So if I is 0, it will take Mitesh, and then it will concatenate this mail ID. Okay, and similarly it will the code will execute till the end of this list. That's it. Here in the for I in the range of 5, so 0 to 4, and then simply I want to take a square of each and every element of that list. So see now, so 0, I is 0, 0 square is 0, then I value increase 1, 1 square is 1, then I value increase 2, 2 square is 4, then 3, 3 square is 9, and then 4, 4 square is 16. Okay, so it will if you start if you give the range, it will start from 0 to n minus 1. That's it. In the while condition, okay, in the while condition, so this is the code, yeah, while condition, and then in the independent block you have to give the statement. That is the code block. Okay, here I'm taking the input, this in this statement I'm taking the input from the user. Okay, and then I have to typecast that input, because initially that input is in a that input is a string, but I have to typecast into int. Okay, and then I want to find the factorial of that particular number. So see here. So suppose I give 4 as an input, and then if I enter, so the 4 factorial is 24. Okay, so see, factorial is 1, and then x value is 2. Then I want to so this is the condition while x is less than equal to n. So n is now 4, x is, so 2 is less than is equal to 4. So this condition is true, so it will execute n factorial. So n factorial is equal to n factorial into x, so 1 into 2, and then it will it will add 1. So 2 plus 1 is 3. So x is now 3. Similarly, the condition will execute till this condition satisfied. Okay, and in the end it will give you the factorial of this number. That's it. And then this is very interesting code. So suppose I want to suppose I think we all know, suppose like if I want to give somebody some money, and then in the next on the next day, suppose I want to double that money, and then the process will go on till the end of the month. And then suppose I want to identify how much will be the money that particular person will get from me. So that is the code. So this is the code for that condition. So in the end of this month, in the end of the month, you will get this much money. So simply while loop, you can write this interesting codes. Okay. So now we will move on to the functions. Okay. So functions are very useful. If you want to suppose if you are implementing some suppose if you are implementing some algorithms, or you are doing some very hardcore coding. In that case, functions are very important, because you want to reuse your code multiple times. In that case, simply by calling a functions, you can reuse your code. Okay, so in Python, the syntax for writing a function is you have to write a def, then name of the functions, then the parameters. What are the parameters you are passing to your functions, and then that is after that, in the intended block you have to write the code, and after that you have to return a particular value. That's it. So here I'm writing a functions area of a square, and for that functions I'm passing two parameters, length and breadth. Okay, so and then after getting a parameter from a user, okay, it will perform operation area is equal to length into breadth, and it will return area. Okay, so if I execute the statement, and then here I'm calling a function. Okay, so here I have defined the function, and here I am calling a function. So I'm passing the two parameters. So length is 2 and the breadth is 3. Okay, after executing this cell, I'll get output 6. Okay, so simply that function is returning a value which is nothing but the area of a square, area of a rectangle, you can say. Okay, then function with the default argument. Okay, so see here. So see here, I have defined a function, okay, which takes name is equal to, that is the empty space. Okay, now I'm calling this function twice. So greet Harish. Okay, so first time it will print hello Harish. Okay, and the second time I'm not passing any argument or any parameter. Okay, so simply it will print the hello, because I am not passing any parameter. So it will take an empty string and simply it will print the hello. Okay, so here start value and stop value. So printing the square of the number starting from the start value including. So here, so here printing the square with start value and stop value. So see here in that function. So this is the functions which will print the start value 5 and then this 2. Okay, so in the Python there is a thing called nested functions. So nested functions are the functions which are defined inside a functions. So there are the two functions, outer functions and the inner functions. Okay, outer functions and the inner functions. So these are the nested functions are very useful if you don't want to use class, if you don't want to use the class and object in your code. In that case, the nested function can be very useful. Okay, so simply I have written here the two functions. The function one is the outer functions and the function two is the inner functions. Okay, so function two is inside the function one. Okay, so while accessing the element, while accessing the code of these two functions, you don't have to call this function two. Okay, because function two is inside the function one. Suppose you want to perform or suppose you want to perform an operation which is defined by this function 2, you simply have to call this function 1. If you call this function 2, it will give you an error. Okay, so simply if I run this, so in this function 1 is printing hello from the outer function and function 2 is printing hello from the inner function. Now what will happen if I call this function 1, our control will go to this function 1 and it will print hello from the outer function. Now our control will not execute this statement. Our control after printing this outer function, our control will go to this function 2, because From here, I am calling this function 2. So our control will go to function 2, and after that, it will execute this function 2. And after that, it will print hello from the inner function. See here. So it will print outer function, hello from the outer function, and after that, it will print hello from the inner function. That's it. Similarly, inner function access the variable of the outer function. So how the inner function access the variable of the outer function, we will see. So here there is a outer function. Okay, so it is the hidden from the outer code. Okay, and then there is an inner function which will return x, which will return the x plus 2. Okay, and then y is equal to inner increment x. So this statement is the code of this outer function, not the inner function, because you see this y is equal to inner increment x is outside the intended block of this inner increment function. Okay, so we will see after running this code. We'll see here, I am calling this outer function 5. I'm calling this outer function where I am passing the parameter 5. So now my outer function got the parameter 5. After that, it will print, it will execute this statement, y is equal to inner increment. Okay, so uh, inner increment x. So inner increment 5. Okay, it will return x plus 5. Okay, x plus 5, and then it will print after that it will print x plus x and y. So first it will print 5, after that it will print 7, because our inner function is incrementing the value by 2. Okay, so now we'll move on to the Python functions or Python packages. Okay, so the Python here in Python we have various inbuilt libraries. Okay, or packages. Okay, so the renowned packages of Pythons are NumPy, Pandas, Math, Matplotlib. Okay, so those are the some renowned inbuilt libraries of Python. Okay, the NumPy we can use NumPy for operations in on a data frame or in a matrix. Okay, suppose you want to take a dot product, suppose you want to multiply two matrices. Okay, or take a dot product or addition, multiplication, division, whatever. That operation can be handled by the NumPy library. And then suppose you want to pre-process your Excel sheet or your CSV file or your data frame. In that case, you can use the pandas. Okay, and suppose you want to visualize your things. In that case, you can use Matplotlib library, or there is another library, SNSBorn or CBorn. Okay, those are the libraries you can use for visualization purpose. Okay, so we'll see those library one by one. Okay, so here I am importing a math. Okay, importing a math. Suppose, and here I am taking the square root of 100. So with the help of this math, so in order to import, a library, there is a simple function called import math. Okay, and suppose if you are using a Jupyter, and your Jupyter and in your Python environment there is a, suppose it doesn't exist a math library, so simply you can install like this. Install math. Install math and then run this cell. So it will automatically install. So my notebook already include this math library, so I don't have to install it again and again. Once you install a library, it will stay forever. Okay, so now with the help of this math, suppose I want to find the square root of this element, square root of 100. I can simply use these functions. Okay, so you simply use this function math dot square root. Okay, it will give me the square root of 100. Okay, then suppose I want to find the suppose I want to do the 100 uh, 100 to the power of 0.5. Okay, or square 100 to the power of 0.5 means that is the square root of 100. So it will give me a result. Okay, suppose instead of 0.5, suppose if I have to 3, so 100 to the power 3, so it will give me the output. Okay, then uh, here x is a 10 and y is a 1. Okay, and then I'm running a for loop I in the range of 1 to x. 1 to x means 1 to 10. So my for loop will run from 0 to 9. Okay, and then I'm doing the operation on every element. Y is equal to y into I. So this is similar to this operation is similar to y is equal to y into I. That's it. Okay, so it will give me the factorial of 10. Factorial of 10. Okay, so this is, suppose I want to find what is the factorial of 10. So for finding the factorial of 10, I wrote this much line of code. But simply if I use the inbuilt function in a math library, I can I can find, or I can get the output. Okay, and there is another way to import a library. Import math as m. Okay, so here I simply import math. Here I simply import math. Therefore I have to write math dot factorial. But if I import libraries like this, import math as m, so I don't want to I don't have to write math every time. So I can write m dot factorial. Okay, m dot factorial. This is useful if your name of your library is very large. Okay, then simply like here I'm importing previously I import only math. Okay, and then I'm accessing the function from that math library. But sometime if I know the functions the included in that particular library, then simply I can import from math, import factorial. So if I import a function like this, then I don't have to write anymore m dot factorial or math dot factorial. Simply I can take I can write a function, I can pass the argument, I can get the output. That's it. Okay, and then suppose if you want to find the time required, suppose if you want to find the time required. Now see, here I wrote a rigorous code or the 2-3 lines of code for finding the factorial of particular number, and here I'm using by default library. Okay, so suppose I want to find which one will take more time. So if I run this code, see, if I write a code, very basic code, it will take 0.0014 seconds. Okay, 0.0014 seconds. But if I use the predefined library, it will take 0.00016. So this is the case. If you are using a predefined library, it will take very less time. Okay, so this is very useful. Right now, you may see this is a very simple thing, but like if your data set is very large, if your data set is very large, suppose it is in the MBs and GBs, okay, and if you are using a uh, very complex module such as like TensorFlow and PyTorch, okay, in that case, if you instead of writing a very simple code, if you are using a predefined libraries, it will it will decrease your execution time. Okay, so see, like file handling is very important aspects of this Python coding. Okay, file handling, like importing a file to your code. Okay, so importing a file and uploading a file. Okay, so these are the like very important things. Okay, suppose you have a data set. Suppose you have a data set in a CSV format. Okay, how you have to, how you can import in your Colab notebook. Okay, so there are various way to importing your data set in your Colab notebook. Okay, I'll show you. So this is the code. Like for the first thing you can simply go to this thing. You can simply go to this file. Okay, you can go to upload. Okay, you can go to upload. Simply you can right click here, upload. Go to upload. Okay, and uh, then there is a suppose you want to uh, import a data set. So this is the file which I want to import in my notebook. So simply you click here, you go and you upload your data set. The disadvantage of this thing is the disadvantage of this thing is, suppose if you are disconnected while execution. Okay, the file will you have to reload your file, or you have to re-import your file every time. Okay, so since if your data set is small, then in that case you can every time whenever there is a disconnection. Okay, you can every time you can import your file. But if your data set is too large, suppose your CSV file is uh, 1 GB, 2 GB. Okay, in that case importing a file itself, it will take more time. Okay, so in order to save time, simply what you can do, you can go to your drive, Google Drive. Okay, you upload your data file here. Okay, you can upload your data file here in your Google Drive. Okay, so similarly I upload my data file here, or data set here, and then you click on that, right click on that file. Okay, click on this get link, click on this get link. Okay, it will give you, a link. Okay, it will give you a link, this link. It will give you a link. Suppose if I copy this link and if I paste it into, paste it into, okay, if I paste it into here, so see, so this is the link. Okay, this is the link. Now in order to access this, see, the file, the this, so this is the ID of your file. This is the ID of your file. So simply you can remove these things. Simply you can remove these things, keep only these things, and write it here, ID equal to, that's it, that's it. And then you can go here. Okay, and you can paste it here. Okay, we'll see. So this is the some uh, importing a file, from Google Colab. Okay, so simply if you execute these statements, it will ask for your authentication. Okay, ask for your authentication. You have to give the authentication first. Okay, so simply you just have to allow here. You go here, you allow these things, whatever the necessary requirements. Okay, and then you have to copy these things. You have to copy this. Okay, and then you paste it here, hit enter. Okay, now you gave the authentication to the Google Colab, for accessing your data. Okay, now I am importing a panda. Okay, now see, this is the thing. So here the ID which I got just now. Okay, so right just now I told you how to get an ID. You go here, you right click on this file. you go to get link, okay, simply you copy this link, okay, and then you copy this link, you paste it here. That's it. Okay, you copy this link. That's it. Okay, you remove this thing, and then here write ID equal to, that's it. Or you can remove a whole thing. It will also work. Okay, that will also work. So but you have to keep it here id equal to this thing. Okay, so that your code will know which data set to access. Okay, so similarly I already gave the id, so I don't have to give every time. And then if I run this code, and suppose I want to see the data set. Now see, this is the file which I have imported. So this was my CFC file which I have stored in my Google Drive, and then I am accessing the data set from my Google Drive. That's it. So this is the data set which I have imported just now. Okay. So now we'll see the operations. Okay. So see, so this is the file. Now I am renaming this file. I'm renaming this file to mobileclean.csv. Okay, mobileclean.csv. Okay, now what I'm doing, I'm opening this file in a read mode. Okay, I'm opening this file in a read mode. Mobileclean.csv is already available in my in my file handler. Okay, and I'm opening this file. Okay, so simply I'm opening this file, and then I'm reading the line of that particular file. So s is equal to file.readline. Okay, and simply if I print this s, it will give me the features, or the whatever the features or whatever the columns are present in my data file. Okay, and then if I split s.split, it will create a list. It will create a list of each and every feature of my data file. So these are the features like sim time, aperture, GPU rank, weight, standby time, processor frequency, thickness. So these are the feature of my data set. And then I'm closing this file. So here I open this file, and here I'm closing this file. After closing the file, you can't perform any operation on your file. So in order to perform any operation, the file must be open. Okay. So see here. Now I close my file, but now in the next step, in this statement, I want to read the line of my file, read some line. But see, it will give me IO operation on closed file, input output operation on a closed file. Now my file is closed. Similarly, now I want to read my file. Okay, here I'm opening the file, then I'm reading the content. File.readline. This statement will give you the features exist in your file. File.read will give you the content, whatever the content. Okay, whatever the content exists in your file. Okay, then here I'm splitting each and every sample of my file, and then I'm separating with this dash line, with the this dashed line. Okay, every sample I'm separating, and uh, separating with this dashed line. Then here I'm creating file. Okay, so that's it. Then in the case of NumPy, I already told you the NumPy is the library which is used for performing the operation on a on an imported data set or on a matrix. Okay, so whatever the operation like identifying the eigenvalue, eigenvector, identity matrix, okay, dot product, whatever the operations we perform on a vector, those all the operations can be handled by this NumPy library. Okay, so here I'm importing a NumPy as an NP. Okay, so now I have imported in the NumPy. Then I am taking an array 1, 2, 3. Okay, X, which is an array which contain element 1, 2, 3, and then I want to check the type. What is the type of this X? So this is the ND array, n-dimensional array. Although it is only one dimensional array, but it's telling me that it's a n-dimensional array. But see, now see here, L is a list. L is a list. It is not an array. L is a list, but in order to convert this L into array, I have to write np dot as array and in bracket L. Okay, so it will create a list into array. Why it is necessary to create a list into array? Because whatever the operation you can perform on an array and perform on a list. Okay, so like if you are implementing any code or if you are implementing any algorithm, okay, and if your data set contain a large amount of features, okay, in that case, uh, uh, simply by converting the samples into a list, you can't perform much operations. Okay, because your data set contains the features, rows and columns, so it is a whole matrix, not a list. Okay, so it is very important to convert a list into a, sometimes like if you whatever the operation you are doing, if it is not accessible on a list, you can convert that on a array. You can convert that list into array and then you can perform the same operations. Then suppose I want to print the X. Now see the list. So previously it was a list because every element was separated by comma. Now after converting into array, so it is not separated by comma. So this is the difference. Then I want to convert into float array. So this is the integer array. This is the float array. So simply you have to give the np dot as array. You have to pass the list and simply you have to write here float. That's it. Then suppose you want to know what is the shape of your data set. Okay, shape of your data set. So simply you can write x dot shape. It will give you the shape of your array. Okay, so this is simply a row array, or you can say the column array, 3 cross 1 or something like that. So this is a simply a row array. Then suppose if you don't know if you don't know the functionality of any function, if you don't know the or the function of anything, then you can simply write np.array and after giving the followed by the question mark, you can the collab will provide the documentation for that particular function. Okay, so here I do suppose I want to know more about the array, so simply I can write np.array followed by the question mark. It will give you what is the function of that array, what is the operation of that function, and then how to operate, what are the parameters you have to pass, what are the different operations you can perform with the help of examples. See here, it gave all the documentation with including the examples also. So it is very handy to learn things in Colab. Okay. So here I'm taking now, previously it is a only one dimensional array, but I want to create a two-dimensional array. So two-dimensional array contains the multiple rows and the columns. Okay. So here now I'm taking a two-dimensional array. np.array 1, 2, 3, 4, 5, 6. Okay. So now if I print this X, so this is the two-dimensional array. This is two rows and three columns. Okay, two rows and three columns. So and now if I want to see the shape. What is the shape? So it is 2 by 3 matrix. It is a 2 by 3 matrix. Okay. And then suppose you want to slice the matrix. Okay, similarly, the way we slice the list and the list, tuple, and then sets and the dictionaries. Okay, similarly you can slice the array also. Okay, so suppose you want to access, so 1x, x in a bracket 1 2. Okay, 1 2 means what will it give? 1 2 means, see, I told you in Python every array or every data structure start from 0. Okay, so this is the 0th row, this is the first row, this is the 0th column. So 1 4 is the 0th column, 2 5 is the first column, 3 6 is the second column. Okay, so one row, second column, first row, and second column. This thing, 3 and 6. So first row, second column. So it will give you the element 6, because 6 is the first situated in a first row and in second column. That's it. Now suppose I want to access the element in a 0th row from 0 to 2 column. Okay, in a 0th row from 0 to 2 column. 0 to 2 column means it will give 0 to 2 means 1. Okay, 1. So it will give 0th row 1 to 0 to 2. 0 to 2 means 1 to 2. So it will give you the element 1 and 2. See? It will give you the 0th row and column 0 to 2. So, and then suppose 0th row and all the columns. 0th row and all the columns. So it will give you the first row. 0th row. 0th row. So 0th row is 1 2 3. Then suppose you want to take an array, suppose you want to take a matrix of 4 by 5 which contain all the elements 0. Okay, 0 matrix of dimension 4, 4 rows and 5 columns. So similarly you can take np.0 4 row and 5 column. So if you print this, it will print you, so this 4 row and 5 columns, all the elements are zeros. Similarly, if you want to take identity matrix of 4 by 4 dimensions, we can take as well. Similarly, np.I give you identity matrix. Okay, it will print the, or it will generate the identity matrix in which the diagonal element are 1. Okay, suppose you want to generate a random matrix of dimension 4 by 5. Okay, 4 rows and 5 columns. Simply you can write np.random.random. Okay, np.random.random. It will generate a matrix of dimension 4 by 5. Okay, simply this is the matrix. Okay, so the whatever the random number you are generating, it's in the normal distribution. Okay, normal distribution. If you plot this one, it will generate a Gaussian Weyl curve or the Gaussian curve. Okay, so here simply if you want to take the suppose if you want to, so here Z is a matrix. Okay, so suppose you want to transpose this matrix. Transpose this matrix means suppose you want to interchange these rows and columns. So simply for transpose you have to do x dot t. It will transpose this matrix. So, and I am storing the transpose matrix into Z variable. So if I print this Z variable, it will give me this. So previously it was 4 by 5, now it's 5 by 4. It transposed the original matrix. Okay, then suppose you want to convert in or reshape that matrix. Okay, so now we have 4 by 5 matrix. 4 by 5 matrix means it will contain 20 elements, and now I want to reshape it into what we can say a column matrix. So x dot reshape 20 comma 1. Okay, so it will generate a column matrix. See, if I print this, now this is a column matrix. All the elements are in a single column. That's it. Reshaping. Okay, so the reshaping is very useful if you are reshaping is very useful if you are doing a deep learning, of if if you are building a deep learning algorithm, okay, in that case, if you have a image, color image or grayscale image, in that case, for flattening your array, you can use the reshape function. Okay, so here arrange np.arrange means it will generate number in a it will generate a sequential number. Okay, from 0 to 5. Okay, 0 to 5 or 0 to n number. Okay, if you want a sequential number, that's it. Then here I'm taking B, and then simply I took a array A, okay, which contains 0 to 4, and then B, which also contains 0 to 4. Then I'm doing a operation. So because this is a Python, okay, because this is a Python, you can simply you can simply uh, perform a basic algebraic operation like a plus b. See here, a plus b is not a single variable. A plus b is a array. Okay, but in Python there is a provision you can simply write a arithmetic operation and it will give you the result. So see, a plus b, it will give you a result a minus b 0 0 0 a into b. So it is the element wise multiplication of both the arrays, right? See, a, and if you are writing a plus b, automatically it will increment each and every element in your array. That's it. Similarly, if I taking the if I take random array of 2 by 3 dimensions, okay, and then so this is the original array, this is the original random array A, and if I want to perform operation a plus 1, so it will increment each and every element of this array by 1. But since this is a Python, you can simply write this kind of algebraic operations. Okay, if it is a C language, you have to write a rigorous for loop for these operations. So this is the advantage of Python. Then floor loop. So here I am taking the random. Here I am generating the random matrix of dimension 2 by 3, and then I am multiplying each and every element by 10. Okay, and then I am taking the floor value. Okay, so it will give me the floor value. So if you don't know the function, simply if you put your then np.ones, here I'm generating the ones matrix of dimension 2 by 3. Here I'm generating the ones matrix of dimension 3 by 2, and simply I'm taking the dot matrix of A and B. So this is the dot matrix. This is the dot product of A and B. Okay, then for transpose, then ones 2 by 3 ones matrix, then A dot sum, it will give the addition of all the elements in your matrix. Okay, so the addition of all the elements of your matrix is 6. Okay, and suppose you want to add the element on the for the particular row, or if you want to add the element for a particular column, you can also do that things also. So a dot sum axis 0. Axis 0 means it will add the element by column. It will add the element by column. See, so a dot sum axis 0. Axis 0 means it will add the element by column. So it will give you 2 2 2. And if you want to add the element by row, you have to give the axis is equal to 1. So if you give the axis is equal to 1, it will add the element by row. 3. 1 1 1 1 plus 1 plus 1 is equal to 3. And then if you want to find the maximum element, you can find the maximum element, that is 1. 1 is the maximum element. So these are the simple operations, like with the help of NumPy you can do. Okay, now we move on to the visualization things. Okay, visualization. So visualization is very important thing. Like if you are working in a machine learning or a data science, or if you are working on a deep learning, suppose you are building a very rigorous module. Okay, so or if you are proposing any algorithm in order to in order to validate your proposed module, you have to visualize things. Okay, suppose you want to plot a convergence curve in the case of optimization. Suppose you want to plot ROC AOC curve. Okay, suppose you want to plot a heat map. Suppose you want to plot a scatter plot. Okay, so all those things are very useful in order to analyze your results, or in order to analyze your uh, proposed module. Okay, so in Python, there are various libraries, okay, inbuilt libraries. With the help of them, you can plot your results. Okay, so the matplotlib is a very basic library. Okay, other than matplotlib, there is a cbon. Okay, cbon is kind of advanced library. You can print a you can print a 3D module. Okay, or you can print a 3D results also. All those things are accessible or very handy in Python. Okay, so here I'm importing the matplotlib dot pyplot as a PLT. Okay, so here this is the functions by which I'm plotting the results. Okay, and every time I don't want to write matplotlib dot pyplot, so I'm accessing these functions as a simple name. Then I'm importing numpy as a np. Here I'm generating a random number. Okay, I'm generating a random number and I'm generating a 10 random number. Okay, and I'm so this 10 random number. Now I want to print this. Now I want to plot these numbers on a x and y axis. See here. So this is the indexing on the x-axis. You can see the indexing. On the y-axis, there is a value. There is a value of particular random number. So see here. In plt.plot, I have to pass. I have to pass this matrix or the array, n-dimensional array, and I have to specify the star or what kind of plot I require. Okay, and then after that you have to write plt.show so that it will show the plot at the same time. Then here I'm taking number from 0 to 100, and I'm taking the power of each and every number to the power 2. Okay, and then I'm plotting x and y. So x-axis you are giving taking from number from 0 to 100, and on the y-axis it's taking the power value of particular element. Okay, and then every point is defined or is showing by this plus indicator. Simply, if I convert it into star, it will print star. Then there is another library, as I already told you, cbon is there. Okay, so here I am importing a cbon. Okay, cbon as a SNS. Then SNS.set. I'm plotting the line plot. Okay, so see here, x-axis, x value is line space which contain the number from 0 to 100. Okay, 0 to 100 and 50 numbers. Okay, so it will contain 0, 2, 4, 6, 8, 50 numbers. Okay, 0 to 100, 50 numbers. Then on the y, I'm taking the power of 2 of every element. So here, with the help of SNS, I can simply pass SNS.lineplot x and y. Okay, so x value and y value. See here in the SNS, if I use the matplotlib, it's not giving any grid line in the background. Okay, it looks very empty and it will not give any inference. Okay, how the values are shifting. Okay, how the values are increasing. But if I use the grid, see here in this plot, you can see the very good grid. Okay, so that you can see the every point very effectively how the function is increasing. Okay, now see here I'm importing this mobile clean.csv file. Okay, and this data.head. So here I'm importing this file. I'm importing this CSV file into the variable name called data, and I want to see my file. So here, instead of, so uh, my file contain around 150 200 samples. So I don't want to access, I don't want to see all the 200 samples. I want to access only first 4 5 samples. So in that case, I can write here this statement data.head. So data.head or data.head give you first 4 5 samples and all the features. Okay, so this is your imported file, or your, this is your data set. Okay, so this data set, so I want to give you a quick description about this data set. So this data set contain all the numerical, all the all the all the features are in this data sets are the continuous. Okay, and the last element is a categorical variable. Okay, it's a discrete variable. So we can perform the supervised machine learning techniques on this data sets. Okay. So here, suppose I want to plot the scatter plot of standby time is these features, and battery capacity. So here, this is the battery. So there is one features, battery capacity. So this is the battery. Okay, so this is the battery capacity. Okay, suppose I want to find, suppose I want to identify the, suppose I want to identify the, so suppose I want to identify the relationship between standby time and the battery capacity. So simply with the help of scatter plot, I can find that. So see here, SNS dot scatter plot. On the x-axis, it will show me the standby time. On the y-axis, it will show me the battery capacity. Okay, battery capacity. That's it. So as you can see in the scatter plot, you can also take a look at the outlier in your data set. Okay, so see here, you can see the maximum points in this region. You can see the maximum point in this region. Means if the battery capacity is uh, less than 3,500, okay, and the standby time is less than 600. You can see the more point in this region, okay, and very few points in this region. Okay, you can say these are the outliers. Okay, so this is the advantage of scatter plot. Then again, suppose I want to identify the relationship between standby time and the battery capacity, and the hue is a thickness. Okay, so executing these things, let's see the plot. Okay, so hue is a thickness. So thickness is a features which contain the thickness of your mobile phone. Okay, so 6 millimeter, 7.5 millimeter, 9 millimeter, 10.5 millimeter is the thickness of phone. So you can see the battery capacity and the standby time, and on the same time you can also identify the thickness of your phone. Okay, so if the standby time, you can see, you can give the inference here. If the standby time is less than 600 and the battery capacity is 300, the thickness of the phone is maybe 10.5 millimeter. So these are the inferences you can give with the help of scatter plot. Now we'll see what is the dist plot. So this is the dist plot, distribution plot. Okay, so distribution plot. Here I'm plotting the distribution plot of a standby time features. Okay, so this is the distribution of a standby time. It's a skewed to the right. It's not a proper normal Gaussian curve, but it's a skew. You can see it's a skew to the left skewed. Then standby type. Okay, so this is also some kind of distribution plot. Then in the box plot. Okay, so this is the box plot. It will contain the quartile and the outlier. Box plot is very uh, uh, important when you want to find the outlier in your data sets. Okay, and then expandable memory and the price. Okay, so So this is the expandable memory and the price. So with as compared to according to me, as compared to Matplotlib, if you are using a Seaborn, it will give you more options. Okay, and you can visualize more advanced things with the help of Seaborn. Okay, so this is the heat map. Heat map. Suppose suppose you have very large data sets. Okay, and you want to identify. Suppose you want to identify the features or the things which are responsible for particular type of thing. So in that case, you can use the heat map. So here I have generated the array of 10 by 12 dimensions. Okay, and then every block is showing the intensity of each and every element. Okay, so here so these are some of the basics of Python. So in this session, like we saw the variables, lists, tuples, dictionaries, and then control structure functions, Python packages. Okay, so like I'll share with the I'll share the this Python uh, notebook with the Balakrishna. Okay, whenever like if you want, I'll share, and along with the data file. If you want, you can go through this. If you want, you can go through these codes. These are the very basic. Then you can write on your data set. That's it.
Yes, I'm very happy that I have joined this session. Actually, it's having vision process, teachers are
Hello.
I just having one theory of the the same question I got last year. I just want to much more problematic focus. Many times work with artifact. So what yesterday I was able to submit the assignment on this assignment. I'm feeling very grateful
Thank you for your wonderful session, sir. It was really interesting. Thank you.
Thank you,
Thank
sir.
you for the session, sir.
Thank you, sir. Thank you.
something because I was waiting out of meeting and it was amazing to see that only 1,000 participants are there and now just wait. I think where I think would take us and it
Participants are requested to fill the attendance form.
just please note
Next session starts by 12 p.m.
the station was very good, right? Right to what yes and everything. Today I'm able to get everything in paper. Thanks, sir.
Hello, your voice is not clear, sir. What you said for participants?
Next session starts by 12 p.m. Participants are requested to fill the attendance form for session 1. It is posted in chat box.
Okay.